All right, so today we are talking about inductive reasoning. Inductive reasoning is a way of thinking or a way of explaining things that uses examples to reach a conclusion. So, the old saying, if it looks like a duck, it quacks like a duck, must be a duck, that's inductive reasoning. So, if it looks like a duck, if it quacks like a duck, then it must be a duck. We could also say that that saying is a conjecture because that would be a conclusion based on incomplete information. So perhaps it may look like a duck, it may quack like a duck, but perhaps it's Mr. Right in a duck costume doing a really good duck impersonation. So you may not know it, but I do a pretty solid duck impersonation. Let's see. Just kidding. That's a goose. But anyway, enough about ducks. So a conjecture is just a conjecture is just a conclusion based on incomplete information. It could be true. It could be false. We're just making assumptions based on the limited information we have. A counterexample would be a specific example to show something is false. So, like, I really want to go back to the looks like a duck example again, but I'm not going to let myself do it. So, if I said, all rectangles are squares, you could say, oh, no, no, no. What about this basketball court? It is not a square. So that could be a counterexample to my claim that all rectangles are squares. Not nearly as exciting as the duck example, but we're going to keep moving. So they want us to write a conjecture. This whole chapter, you're going to hear me mispronounce words, and it's going to annoy me, but it's also kind of comical because I can't speak. Write a conjecture that describes the pattern 2, 4, 12, 48, 240. Then use your conjecture to find the next item in the sequence. So looking at this pattern, and they already gave us that 2 times 2 is 4, 4 times 3 is 12, 12 times 4 is 48, and 48 times 5 is 240. So based upon that, what I'm going to say is that, let me pull that up real quick. That's not what we're looking for. What? All right. So based on that, I would say the numbers are multiplied by 2, 3, 4, and 5, and then so on. So I would say numbers are multiplied by 2, 3, 4, 5, and then I'd say ... So I would say the next one is going to be multiplied by 6. So 240 multiplied by 6 would be 240 times 6 is going to equal 1440. So I'm going to say 1440 is going to be my next example. So that would be an example of a conjecture. What's going on there? Why is that happening? So, write a conjecture that describes the pattern in the sequence. Then use your conjecture to find the next item in the sequence. Class 1A. sorry, I lost my train of thought. So my conjecture, so it goes from 1, which could also be written as 1 over 1, to 1 over 4, to 1 over 9, to 1 over 16, to 1 over 25. All right, so what I'm seeing is this is going to be 1 over x squared. And so my first x is 1. Oh, no. Where are we? There we go. So my first one is 1 over 1, or 1 over 1 squared. Then we have 1 over 2 squared, which is 4. Then 1 over 3 squared, which is 9. Then 4 squared, then 5 squared. So I'm guessing the next one is going to be 1 over 6 squared, which would be 36. Write a conjecture that describes the pattern in the sequence. Then use your conjecture to find the next item in the sequence. So we have 1, then 3, then 6, then 10. So what I'm seeing is in these circles, they're adding a row that's 1 bigger each time. So we have 1 row of 1, then we have 2 rows. So we have 1, then 2, then 3 rows. So the next one's 4 rows. So after that, we're going to add a 5th row, which is going to have 5 circles in it. So we're going to have 10 total so we're going to have 15 total circles. So I'm going to say this one is B as well. Make a conjecture about the sum of an odd number and an even number. List some examples that support your conjecture. So an odd number plus an even number. So we have 1 plus 2 is 3, 1 plus 4 is 5, 4 plus 5 is 9, 5 plus 6 is 11. And so if we look at this pattern, they're all odd numbers. So if you add an odd number and an even number, it seems like you're always going to get an odd number. So the answer is the sum of an odd number and an even number ends up being an odd number. So for points L, M, and N, LM equals 20, and MN equals 6, and LN equals 14. So they drew the figure. If we look at the figure, then I would say since LN plus MN equals LM, then the points can be collinear with point N between points LM. So for this, my conjecture would be that LM and N are collinear. So I would say L, M, and N are collinear based upon 14 plus 6 equaling 20. So since those numbers add up, I'm going to say that they're collinear. Make a conjecture about the product of 2 odd numbers. So I'm going to use some examples. So if I do 1 times 1, I get 1. If I do 1 times 3, I get 3. If I do 5 times 5, I get 25. So I'm seeing a pattern that when you multiply 2 odd numbers together, the product seems to always be odd. So I'm going to guess that the conjecture would be that they're always going to be odd. Based on my minimal examples, the product of 2 odd numbers is always odd. Yeah. So our conjectures are really just our educational guesses based on the examples that we see. So given that ACE is a right triangle with line AC and line CE are being equal, which figure would illustrate the following conjecture? So triangle ACE is isosceles and angle C is a right angle, and line AE is the hypotenuse. So I'm looking for a right triangle with two sides that are the same. So I can eliminate B because it does not show that the two sides are the same length. This one has, D has two sides that are the same length, but it has no right angle, so I'm going to eliminate that one as well. So line AC and CE are the same. So line AC and CE are the same. All right, so C is the only one that it works, but let's check and make sure it meets all the conditions. So angle C is a right angle, check. The triangle is isosceles, the two sides are the same. AC does equal CE, and AE is the hypotenuse, so I would say C is our correct answer. So just big picture for this section is that conjectures are educated guesses based on the information given. So we're just trying to make generalizations that may be true or may not be true. We try to make them true, but they're not always going to be true. If you have any questions.